Okay, types of equations. Are you ready? Pause and peruse the objectives and standards, all that good stuff. All right, so there are four main types of chemical reactions. What are they? Synthesis, decomposition, single displacement, and double displacement. So what are they? Synthesis, decomposition. So what do you notice? Sometimes it's called single displacement. Sometimes it's called single replacement. Sometimes it's called double displacement. Sometimes it's called double replacement. Doesn't matter. All right, so let's look at synthesis first. Synthesis means to make, to build. So two or more reactants combine to yield one product. So the general formula is going to be A combines with B to make AB. So synthesis, take two or more smaller pieces to make a bigger piece. Okay, so it's like taking some small Lego pieces and building something bigger. All right, let's look at synthesis happen. Two smaller pieces combine to make something bigger. Two smaller pieces combine to make something bigger. Okay. Decomposition. Decomposition is the opposite of synthesis. So decomposition, breaking down. So one big reactant breaks apart into two or more products. So the general formula is taking AB and breaking it apart into A and B. So decomposition, again, takes a big thing that you start with one reactant, break it apart into two or more products. Let's look at decomposition happening, taking one big thing, breaking it apart into two or more smaller things. Okay. One big thing breaks apart into two or more smaller things. They can be elements, they can be compounds, what I break apart into. All right, then we have single replacement or single displacement. So the way I remember it right here in this formula, the difference between single. So this is single. So see this? Single elements and on both sides. So something is single on both sides, but it's a different substance. So on this side, it was this that was single. On this side, it's this that's single. Okay. So let's look at what it looks like in an actual formula. So right here, single element, right here, single element, but they're different. Here's where the arrow is, the yields, okay? So a different single element on both sides of the equation. So watching it happen, it's gonna swap. So do you see this comes over, new thing comes off. This comes over, new thing comes off. Okay, single displacement, single replacement. Now, we use table J to predict single replacement reactions. So elements at the top. So for metals, it's lithium. For non-metals, it's fluorine. Elements at the top are more reactive. So you can see it tells you they're most active. So you don't have to remember. They don't like to be single. The ones that are real active, they like to be partnered. Okay, so they will replace anything below them in a compound in a single replacement reaction. Let me show you what I mean. So consider this reaction. I have K wanting to combine with CaCl2. So here's K and here's Ca. All right, here is Cl. But I'm not going to even consider Cl because I need to compare the two things that are in the same column. Okay, so will the reaction occur? Well, look, K is alone, it's single. It's more active than calcium, so heck no, it does not like this situation. So yes, absolutely, the reaction will occur. What will the products be? Well, what will happen is K come over and take the place and say, I am sorry, buddy, I am more active than you, you get out of here. And Ca will come and take K's place. So it'll look like this. Why does this formula look different? Why is it not Cl2? Because K has a plus, just plus one charge, and Ca has a plus two charge. This equation is not balanced, but let's not worry about balancing yet. That's kind of our next topic. All right, what about this reaction? So let's look for everything on here. So we have Al, we have Ca, and we have Cl2. I'm going to ignore this because I'm only going to look at the two things in the same column. Well, Ca is higher. So will this reaction occur? No, because the bossy one, the higher one, is already paired up. So the products, it's going to be nothing. There's going to be no reaction. What about this reaction? So let's find everything. So we have F2, Cl2, and Ca. Ignore this. We're only going to look at the two things in the same column. Well, F is higher, so that means F doesn't like to be single. So F is absolutely going to kick Cl out. So F will come and take the place of Cl, and Cl will take the place of F. So what will it look like? Like this. And this is, the formula is correct, so it is all set. All right, then we have double replacement or double displacement. So we have compounds on both sides, two compounds, compound, 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 compound. But what happens is the cation ions and negative ions, the anions, they swap, okay? So they exchange to form two different compounds. Let me show you what I mean. So here Na was with SO4, so Na is going to swap and it's going to be with Cl, and Ba was with Cl and it's going to swap and be with SO4. All right, so again, a double swap. So you can see that happening in this illustration. So in this one, it doesn't tell you what happens, but I started with HCl and NaSO3. So what will happen is H will come with SO3 and Na will go with Cl. All right, combustion. So this is not in the list of 4, but it's an important reaction to remember. So we have a hydrocarbon. So that's something with carbon and hydrogen. Could have other stuff in it too, but it at least has to have carbon and hydrogen. It reacts with oxygen and it creates, it produces carbon dioxide and water. So combustion is a chemical reaction between a hydrocarbon and in the presence of oxygen that produces carbon dioxide and water. So combustion, okay? Hydrocarbon in the presence of oxygen produces carbon dioxide and water. Combustion, okay? Burning, that's combustion. All right, so given this balanced equation, what type of reaction? Well, in order to be single replacement or double replacement, I need to have two things on both sides. So I know these are not true. In order to be combustion, I need to have water, yes, and also carbon dioxide, so no. So I'm down to these two. Well, I started with two things and I ended with one, so it's synthesis. What equation represents single replacement? So anytime I have single replacement, I need two things on both sides. Nope. Nope. Okay, so it's one of these two. Anytime it's single replacement, I need to see single elements and a different one on both sides. Beautiful. Given this equation, what type of chemical reaction? Okay, so in order to be single replacement or double replacement, I need two things on both sides. Oh, I have it. Let's check and make sure it's not combustion. I don't see carbon dioxide and water on this side. So if it's single replacement, I should see single elements, different element on both sides. Which equation represents double replacement? Well, in order for any of the replacement reactions, I need two things on both sides. So I can get rid of this one. If it's combustion, I have carbon dioxide and water as products. So let's see what I'm left with. With double replacement, I have two compounds, 2 compounds on the reactant side and 2 on the product side. It's just a swap. So there we go. What kind of reaction is this? Well, in order to be single replacement or double replacement, I need 2 things on both sides, which I do have. So let's check and make sure it's not combustion. Do I see? Nope. No water and carbon dioxide. To be single replacement, I need to see single elements. Don't have them. Double replacement. Okay, decomposition means starts with one thing, ends with more than one. Here we go. What kind of reaction is this? Well, you can see I start with 2 things, I end with 1. Building, synthesis. Combustion reaction, I need carbon dioxide and water as products. There we go. And what kind of reaction is this? Well, here you can see I started with 1 thing, I ended with more than 1. That's breaking down, that's a decomposition. And that is types of equations. I hope you learned something new today.